Question 4 is about cereals. So we have a table with a bunch of cereals, their manufacturing company, and their nutrition facts, and the rating given by Consumer Reports, which I believe is basically like how much do people like them, um, and also the shelf at a supermarket they're on. So we're going to be answering a bunch of questions related to this data. So part A, we have a graph here, and we want to know what line of code will produce this following output. Okay, so this is clearly a bar graph because the way you differentiate it from a histogram is that the bars are labeled by categorical variables rather than numerical ones. So we can just delete everything that's not a bar graph. So histogram, no, and scatterplot, no. Okay, so we have serial.bargraph by manufacturer or serial.group by manufacturer.bargraph. So in order to get all the manufacturers and their counts in one place, we need to group by the manufacturer first. If we tried to do this bar graph, it would actually spit out probably a bunch of gibberish because we don't know how many cereals were made by each manufacturer without grouping. Okay, part B. All the cereals are represented in these two histograms. One of them is the amount of fiber, and the other is the amount of protein. So which of the following conclusions are justified? Okay, so the first one is that about half the cereals have at least 2 grams of fiber. So let's draw a line at 2. And in my opinion, this pretty well separates it by half. If you take this small thing right here and you put it on top of this bar, it comes out to about the same height. So I would say yes. Okay. The second one is that most cereals have more grams of protein than grams of fiber per serving. So while it is true that the histogram of protein is a bit higher skewed than the one for fiber, this is not a valid conclusion, because there is a way to assign all the cereals so that all these cereals with a lot of fiber have, all the cereals that have a lot of fiber have basically no protein, and all the cereals with no fiber have a lot of protein. And there is a possible grouping such that this is false. So we don't know this for sure, and in order to know this for sure, we would need to know the exact numbers for each cereal. Okay, and on a similar line, we cannot say that most cereals have more grams of fiber than grams of protein. Fourth option is that the number of cereals with at least 4 grams of fiber is about the same as the number of cereals with at least 4 grams of protein. So let's try to do some basic calculations here. Recall that the area of a histogram represents the percentage of data in there. So right here, this bar is all the cereals with more than 4 grams of protein. The width is 2, because it's 6 minus 4, and the height is 5%. So that's about 10%. So 10% of the cereals have at least 5 grams or 4 grams of fiber. Now looking at protein, we have the bars are 1 gram wide, because there's the 2 bar increments are separated into 2. So 10% times 1, that's 10% in this bar. And then in these 2 bars to the right of it, there's a couple more percent, maybe like 3 more percent. So I would say it's basically close enough that we can call it a very similar amount. Okay. And then lastly, cereals with more fiber tend to have more protein. This is not a valid conclusion. We can't say anything just based on the fiber content, how much protein we would expect it to have. Okay. Now we're given the scatter plot of the amount of sugar on the x-axis versus the consumer rating on the y-axis. So which of these conclusions are valid? Okay, so there is a positive association I would disagree with this. I would say there's a negative association. Like you can see the line is like trending down. So we would check the box for negative association. We would not check the box for no association. Okay. And then it says for most cereals, the rating would reduce if the manufacturer added more sugar, and then the other ones are increased and the rating would not change. So all of these are incorrect because one of these being correct would apply a causal relationship between the amount of sugar and the rating, and we can never prove a causal relationship from just a scatter plot. We would need to do an experiment by manipulating the amount of sugar to see if the rating changed to conclude a causal relationship. So this is purely an association. We cannot say anything about whether one causes the other. Okay. Part D. So suppose we want to predict the CR rating for a new cereal based on the sugar content. And the way we do that is we're going to go back up here to this histogram and take all the cereals within 1 gram of it, so plus or minus 1 gram, and average their rating to predict the rating of a new cereal. Okay. So def predict rating, and we have a comparison group. So comparison group are going to be the cereals that are within plus or minus 1. And the way we do that is by using the where function, because where takes specific rows out of a table. So cereal.where sugars, and since we're looking at a range, right, of like plus or minus 1, we can use the predicate function r.between, and it's going to be sugar, which is the parameter given to us in the function, minus 1, and sugar plus 2. The plus 2 is kind of odd because it's going plus or minus 1. However, r.between does not take into account the top value, so we need to add one more so that it recognizes sugar plus 1 as a value that it should be looking at. So then we're going to return the average sugar, or the average rating, of those cereals. So we can do np.mean of comparison group dot column rating, and that'll correctly predict our rating. Okay, part E is what range will be the predicted rating for a cereal with 1 gram of sugar per serving. So let's go back up to this scatter plot right here. So 1 gram of sugar is about right here. So we want to look at all the sugars between 0 and 2. So these are going to be included, and I think all the way down here. So we want to take the average rating of these, and while it is possible for us to go and figure out an exact number for the rating of each one, we're not going to do that because it's a little bit complicated and just tedious. What we can do is just look at our multiple choices. So 30, 40, 50, and 60. So 30 is down here. It's impossible for the average to be in that range because none of the values are down there. Same thing with 40. 50 is possible. However, I believe it's a little bit low because there's a large concentration of points right here, which is way above 50. And the last option is 60, which is somewhere around here, and that's the correct answer. It's right in the middle of our values. Okay. So now part F is to fill in the blanks to add a new column to cereal containing the prediction. Okay, so the way we can add a new column by using a function on a different column in that table is the apply function. So we're going to apply the predict rating function, and we're going to apply it on the column sugars. Okay. Oops, let's close the parentheses. So now cereal equals, now we want to add the column to it, so we can do cereal.with column, and we're going to call this column predicted rating. And what array do we want to use? We want to use predictions. Okay. Part G is we want to see how well our predictions are doing. So write a Python expression to figure out the absolute average error for all of our predictions. So the absolute error is the absolute value between the difference of our predicted and our actual values. So first it takes the average error, so we'll do np.mean, and then it's the absolute value, so let's just do np.abs. And now we want predicted minus actual rating. And we can get those columns out of our table pretty easily. Serial.column predicted rating minus serial.column rating. So what this is going to do is it'll take the two arrays of the columns, subtract them, take the absolute value of each element in it, then take the average of the array. And that'll give us our correct absolute error on average. Okay. Part H. We want to make this table right here that has the manufacturer on the vertical column labels, and we want the shelf number to be the row labels. And it's going to be grouped by the average amount of calories. So the way we can get a new table based on two of the column labels is the pivot function. So the first two elements of, or the first two arguments to pivot are the column labels and then the row labels. So it's going to be manufacturer, comma, the shelf. And then the next argument is the column that we want to aggregate the data by. So all these numbers in the middle, we're going to get them from calories. So we're going to feed in calories, then the function that puts them all into one value, and that's going to be np.mean, because it's taking the average number of calories.